Welcome to this explainer. Today, we are completely cutting through all the cryptocurrency hype and the crazy complex math. Instead, we're going to step into the shoes of a business consultant to look at blockchain for what it truly is. And that is the ultimate infrastructure upgrade for your bottom line efficiency.
Here is our roadmap for today. We'll quickly rethink traditional business ledgers, break down decentralization and immutability, and see how networks actually reach agreement. Then, we'll dive into securing the blockchain network, automating with smart contracts, and wrap it all up with some real-world business applications.
All right, part one, rethinking traditional business ledgers, and really, the pain point of centralization. To understand why blockchain is such a game changer, we first have to highlight the glaring vulnerabilities in the systems that businesses rely on every single day.
So let's actually contrast the old way with the new way. On one side, you have your traditional centralized databases, like a standard bank ledger. These are highly vulnerable to a single point of failure, and honestly, you're constantly paying expensive middlemen just for the privilege of trusting them. In fact, globally, intermediary fees cost businesses hundreds of billions of dollars every year in wasted operational expenses. But then, on the other side, blockchain offers a cryptographically secure alternative. We're talking decentralized security, immutable records, and the complete removal of those hefty intermediary fees.
Moving right along to part two, decentralization and immutability explained, the paradigm shift. Let's introduce the core solutions that make this tech fundamentally different from anything sitting in your current IT stack. Okay, I want you to think of blockchain's immutability, kind of like carving a financial record literally into a stone tablet, rather than just typing it into some shared digital document. Once it's carved, millions of identical copies of that tablet are distributed worldwide. If someone wants to secretly change a record, well, they'd have to physically recarve their tablet and somehow convince the entire world to accept their forgery. It makes cheating prohibitively expensive and, better yet, instantly detectable.
So, how are these digital stone tablets actually formed? It's a literal step-by-step chaining process. First off, a transaction receives a permanent timestamp. Second, the data is run through a mathematical algorithm to create a fixed-length digital fingerprint, or a hash. Finally, and this is the absolutely brilliant part, this new block physically locks into the previous block by including the previous block's hash right in its own header. If you try to change old data, the hash changes and the whole chain instantly shatters.
Which brings us to the absolutely crucial point here, decentralization. By distributing these linked blocks across geographically separated nodes, or, just computers, we completely remove the central authority. This protects your business systems from those dreaded single points of failure. I mean, hacking one computer does literally nothing if millions of others still hold the true record. It builds absolute trust, all while creating serious financial efficiency by just cutting out the middleman entirely.
But, this naturally raises a super logical question. If we fire the middleman and there's no central bank pulling the strings, how do thousands of independent computers actually agree on what the truth is?
And that brings us to part three, how networks reach agreement, or the mechanics under the hood. Let's shift our focus to the actual engine of the blockchain, consensus mechanisms.
The two major engines for reaching agreement are proof of work and proof of stake. Now, proof of work requires miners to use massive amounts of computational power to solve complex puzzles. It's incredibly secure, yes, but it consumes vast amounts of energy. On the flip side, proof of stake chooses validators based on their economic stake in the network itself. Because there's no competitive puzzle solving involved, it drastically lowers energy consumption, which makes it way more scalable for enterprise-level businesses.
To keep these networks running at lightning speed, they use something called Merkle trees. Basically, these act as super efficient summarizers, condensing massive sets of transactions down into a single hash. For your business, this means you can instantly verify the integrity of your data without having to download the entire terabyte-sized blockchain. It's just massive operational efficiency combined with instant detection of any unauthorized modifications.
Part 4. Securing the blockchain network, risk management, and cryptography. Look, if you're taking this to your boardroom, their most pressing concern is absolutely going to be security. So let's tackle those network threats head-on.
We can actually apply the classic CIA security triad here to prove how blockchain naturally defends against systemic risks. For confidentiality, sensitive business data can simply be stored off-chain or heavily encrypted, so only authorized parties can even see it. For integrity, those cryptographic hashes we talked about completely prevent any improper modification. And as for availability, Having a globally decentralized network of nodes absolutely eliminates the single point of failure that usually takes down traditional corporate servers.
Now, we do have to look objectively at the threat landscape. Take the infamous 51% attack, where a rogue entity gains majority control. While that is a risk for tiny networks, on large enterprise proof-of-work or proof-of-stake chains, it is simply economically impractical. No one has the money for it. What about Sybil attacks, where someone uses fake identities to flood the system? That's easily mitigated by strictly limiting outbound connections per IP address. And classic denial of service or DOS attacks, well, they naturally bounce right off because there's literally no single server to crash.
Down at the user level, security really all comes down to your keys. Think of your public key kind of like your mailbox. It's your verifiable receiving address, and it's completely safe to share with anyone. Your private key, however, is like the biometric lock on a bank vault. It is your ultimate digital signature to verify transaction authenticity. If you lose the vault combination, you lose your assets. So it's absolutely your ultimate personal protection mechanism.
All right, part 5. Automating with smart contracts, the automation engine. Let's transition from just securing our data to actually putting that data to work automatically.
Enter the smart contract. You can literally just think of smart contracts as pure automated business logic. They are simple, self-executing agreements where the terms are written directly into lines of code. Think, if product is delivered, then release payment. Because it executes perfectly on code across this decentralized network, you save a massive amount of time. You completely wipe out manual reconciliation errors, and you bypass those hefty legal fees. It's a real game changer.
But listen, because code is law here, mistakes are permanent. Actually, scratch that. Let's call them catastrophic. If your team is building these, security has to be paramount. Keep the contract logic incredibly simple. Always build in safety valves or off switches to pause execution if a bug pops up. Rigorously review your code, offer bug hunting bounties, leverage well-tested tools from the community instead of reinventing the wheel, and please exercise extreme caution when interacting with outside code.
Finally, Part 6, Real-World Business Applications, or as I like to call it, the ROI. Let's see how all this underlying technology translates into tangible use cases that directly impact your bottom line.
Take supply chain management, for example. Look at this timeline right here. On day 1, a component's origin is recorded immutably on the ledger, which creates absolute proof of existence. By day 5 in transit, automated IoT sensors log the temperature and condition directly to the blockchain. Then, by day 10, the final consumer or the assembler can look at the ledger and completely verify the authenticity of the part. That is total transparency and zero fraud.
And that ROI, it literally extends everywhere. Real estate is utilizing tamper-proof storage for title registries. Governments are using it for secure record-keeping and digital identity management. And in finance, my goodness, settlements that used to take days and cost an absolute fortune now settle in seconds. The sheer financial efficiency created just by removing the traditional middleman is staggering.
Which really leaves us with one final provocative thought to chew on. If smart contract code becomes the new law and corporate ledgers become as immutable as stone tablets, the old way of doing business is officially obsolete. So ask yourself, is your business infrastructure ready to adapt and thrive in a decentralized economy? Thank you so much for joining me on this explainer. Keep learning, keep building, and I will see you in the next one.